Greetings and welcome, friends. Mr. Waddy here. This is a great day. We've been representing data and points with lines. We've been working with linear equations. You guys know about slope. You know about y-intercept. You know about x-intercept. You know about the point-slope form, the slope-intercept form. You can find equations of lines that are perpendicular to other lines that pass through points. But today we're going to talk about scatter plots and lines of fit. All right, and so here's an exploration problem just to kind of give you an idea of what we're doing. All right, it says a survey was taken of 179 married couples. Each person was asked his or her age. The scatter plot shows the results. All right, so you can see like each of these was a different person. Now these points I want you to recognize are not all on a line, right? If they were all on a line, then they'd all be like lined up, but they're not, right? They're kind of like a blob, right? Almost, right? It's like a bunch of different points. But it says draw a line that approximates the data. Yeah. And I mean, if I draw a line, like, is this line a good representation of that data? No, because like not many of the points are close to that line, right? Is like this line, right? For some of these points, it might hit them, but it doesn't represent the rest of the data. If I wanted to draw a line, let me actually even get my ruler tool out. What if I was just like, well, I'm just going to connect this point to, I don't know, like this point down here. Is this a good line that represents that data? No. Even though it hits two of the points, it's not a good representation of the data. One of the things that I like to think of is kind of like almost draw a football around your data and then connect the farthest points of your data. Kind of works. When you draw a line, you're trying to have it represent the general direction, Austin, please, of the data. So like this, the line that I've got here is kind of the same steepness as those points in general. You agree, right? You kind of see that? And I want roughly, and this isn't always the case, I'm just trying to give you generalizations, roughly have like half the points above the line and half the points below the line. All right? These strategies won't work for every data set, but that's kind of the line that I would have drawn. Okay, and now I want to point out that the line that you guys drew and the line that I drew are all different lines. Okay, they're all going to be slight variations of one another. Now this asks us to write an equation of this line. All right, so that's going to be a little bit tricky. In order to do that, I'd actually have to find 2 points on my line, right? If I have 2 points, I can find the slope. I can write the equation of the line. Now, my line, I don't know if it actually passed through. It probably hit more than 2 of these points, but it's also possible my line hit none of the points of data, and that could be okay. It still could represent the line very well. But let me pick 2 points that are far apart from each other. Yeah, well, yeah. So pick 2 points on your line that are far apart from each other. So I'm picking this point. This appears to be the point 32 for male and 30 for the wife, right? So husband and wife. Bam, 32, 30. And let's pick another point way up here. All right, that appears to be a point that looks like 77. 77. And on the horizontal line, that's 75. Okay, so using those 2 points, if I wanted to find the equation of that line, right, we would find the slope between those 2 points. So I'd have 75 minus 30 over 77 minus 32. The horizontal number, or the y-coordinate, I read by just reading across. The x-coordinate, it wasn't perfect. It was an estimation, but I was like, well, that looks kind of like 77. So that's what I was doing. When I picked a point, I couldn't find ones that landed exactly on the grid. None of the points on my line landed exactly on the crosshairs. So that's what I just kind of had to estimate where those landed. All right, so let's see. 75 minus 30 is 35. 77 minus 32. Wait a minute, guys, wait a minute. 45. Oh. All right, 45 there. And 77 minus 32, what's that? Is that also 45? Did I happen to pick 2 points? I think so. Yeah. And what's 45 divided by 45? 1. So the slope of my line is 1, and then the equation of my line, I could have written this in point slope form. I'll use this point. So mine's going to be y minus 30 equals 1 parentheses x minus 32. And I'll have y minus 30 equals x minus 32 after I distribute. It's not a very interesting distribution. Your lines might be different than mine, right? This is like usually this would have been all sorts of crazy decimals or weird things, and decimals are okay for these types of lines. Absolutely sure that's the case. But you guys can at least follow along with what I've got. And I get y equals x minus 2. And in general, what I would say, I would predict that a 1-year-old man would marry a negative 1-year-old woman. Wait, that doesn't actually make any sense. But that would be what my line predicted. So the slope is 1, so it increases linearly in general, up 1 year, over 1 year, up 1 over year. But the men tend to be about 2 years older than the women. It's probably because, I don't know, the guys that are a girl's age just usually just aren't as mature. I don't know, I've been there, guys. I know. That's probably the case. But, or who knows, there's all sorts of reasons. But obviously there's situations where there are outliers that aren't fully represented by that line, right? There's always going to be exceptions to the quote-unquote rule. And I want to point out this is an approximation. This is not a absolute, okay? This is just an approximation off of real-world data. But once you have an approximation, then you can make predictions, okay? You can make different predictions. And so the conclusions you can make are, you could predict kind of roughly how old they are. You could say that, right, men tend to be 2 years older than women, right? You could make all sorts of things, but they're all averages and predictions. Let's jump down to example 1. I'm going to skip exploration 2. Actually, I'll talk about scatter plots first. Scatter plot. A scatter plot is a series of data points that are represented on a graph, right, as ordered pairs. So a scatter plot is a graph that shows the relationship between 2 data sets. The 2 data sets are graphed as ordered pairs in a coordinate lane. Scatter plots can show trends in data, okay? So it can show give us a relationship that we could start to predict and recognize that when we look at that graph, realize, there appears to be a trend or relationship here. Let's see. So let's look at this, interpreting a scatter plot. Let me get my graph up. I know you guys already got it. Ooh, what are we talking about? We're talking about sugar and calories. Oh dear. Man, they're just going to ruin all of our fun today, aren't they? All right, let's see. I can make that a little smaller. I'll scroll down as I need to. So it says the scatter plot shows the amounts X in grams of sugar, okay, and the number Y of calories in 10 smoothies. And then it says, hey, how many calories in the smoothie are in the smoothie that contains 56 grams of sugar? All right, so of these smoothies, right, I think they said there were 10, which smoothie has 56 grams of sugar? 56 would be about here. There's a smoothie that if I followed this up, they're talking specifically about this smoothie. How many calories are in that smoothie? That's the point, 56 comma what? Well, if I read it across, yeah, 270. So you could say there are 270 calories in that smoothie. Okay, that makes sense. Then it says B, how many grams of sugar are in the smoothie that contains 320 calories? All right, I'll work in a different color here. B, which one has 320 calories? So I'm going up the line. Well, it's none of these ones. Wow, a bunch of these ones were tied with each other. 320, if I follow that across, bam, here's the smoothie that they're talking about. How many grams of sugar were in there? Bing! That's the point 70, 320. And so I would say there are 70 grams of sugar. Sugar. Right? And then they ask me a question that's not about any particular data point. It's about all of them combined. Like, do these tell a story? Right? What could I conclude? It says, what tends to happen to the number of calories as the number of grams of sugar increases? So as I move this way, what's happening to the y? Are they getting smaller? Are they staying the same? Are they getting bigger? What happens to the y values as the x values move this way? Right? It looks like they're getting bigger and bigger and bigger. Right? Some of them are a bunch. There's a bunch of ties there. But if I wanted to talk about that trend, right, my best fit line, maybe, I don't know. I'm trying to think of like where it's more densely located there. Maybe this would be somewhat of my best fit line. I don't know. That's a guess. But this has a positive slope. All right. So the number of calories increase. And I could actually even make an estimate for that. Let's say this point happened to be on my grid and this point happened to be on my grid. If I find the slope of this line, I could actually get even more specific. I could say, let's see, it's going from 250 to 310. So that's up 60 calories for going from 50 to 66 for 16 grams of sugar. So the slope is 60 over 16, which is, let me just get a decimal, 3.75. So that means that the calories increase by 3.75 for every 1 gram of sugar. If I view this as 3.75 over 1, 3.75 calories over grams of sugar. All right, so now I have a rough prediction. Now there are some that's absolutely not true for. All right, my line actually I don't think hit any of their points, but that's okay. It's an overall trend prediction of the data. Let's see. Let me get. Yes sir. Let me. Yeah. So the more sugar, the more calories it tends to have. So in terms of that trend or relationship, the way we describe that is with the word correlation. Correlation. How do those two things relate to each other? It's a co-relationship between them. So correlation is what we would describe that as. Let's see. So identifying correlations between data sets. A correlation is a relationship between data sets. You can use a scatter plot to describe the correlation between data. You about there? Cool. All right. So a positive correlation is when the data appears to be getting bigger, right, as we move to the right. So as x increases, y increases, we call that a positive correlation, which notice this positive is the same as the slope, right? It's the same as when we're describing the slope of the line that would represent that data best, okay? A negative correlation, the line that represents that data would have had a negative slope, okay? So it's a negative correlation. So that means, right, the more that this gets bigger, the less the y became. All right. And then sometimes your data is just everywhere. And like, I couldn't figure out a line that represents this data at all, and that might be because there's no relationship between those things. All right, like one does not influence or affect the other. There's no pattern to discern, and sometimes things like that will be the case. Like, I can't, like I can't pick like, well, how do the number of rings of Saturn relate to the distance it is from the sun? Actually, there might be a relationship there, but nonetheless, like you might like just pick 2 data points, right? How many hours did I play video games, and does that compare to the number of French fries I ate last year? Like, yeah, like it's completely unrelated data sets, and so there's a lot of data in our world, and not all of it is going to have relationships. And in terms of future concepts, not all of it relates linearly either. Sometimes the data will increase faster and faster, and it will be like an exponential growth situation. All right. It says, let's see, tell whether the data shows a positive, negative, or no correlation. So let's see, age and vehicles owned. So here's a person's age and the number of vehicles they own. So this is a person that's 22 years old and has owned 4 cars or currently owns 4 cars. I'm not sure exactly what that means. Probably currently. I don't know. This is a weird graph. Here's a person that's 32 and owns 1 vehicle. Here's a person that's 30 and owns 5 or has owned 5. I don't know. I guess I can't tell the tense of this. Vehicles owned, yeah, presently or past. Right, so here's the data. Does this look like, could I draw a line that represents this data? Yeah, it's kind of all over the place. I'm going to say this is no correlation. No correlation. Okay. All right, here we go. Average daily temperature and the coats sold per day. All right, so when the temperature is 35 degrees, whatever this company is, sells 61 coats or 62 coats. When it's 70 degrees out, they're only selling like 12 coats on a day like that, right? And that's actually sometimes when they'll have their coats on sale. That's what I bought my snow pants on the hottest day of the year a few years ago. That's right, because the store might be like, we just got to move this product. But as far as a relationship between these, what do you guys think? Could I draw a line that represents those? Yeah, I think so. Like, it wouldn't represent everything perfectly, but I think a line kind of like that works. And what's the slope of that line? All right, not like specifically, but in terms of positive, negative, vertical, horizontal, no slope. Yeah, that's a negative slope, and it's a negative correlation. Yeah, aren't you guys glad I already printed out these little graphs for you, so we don't have to spend like 15 minutes putting thoughts on paper? Wow. Yeah, that would be terrible. Terrible, just terrible. Here we go. All right. We're going to do monitoring progress question 3. And here it asks us to make a scatter plot of the data. Now, so if I was to do that, I would look at my X values and I'd be like, okay, they're bouncing between 71 and 92. So I would draw my X-axis and label some values like that. I'd look at my Y values and see like, okay, my smallest number is 1.7, my biggest is 5.5. So I'd fix my scale on my Y-axis and draw them as such. And then I would just plot these as ordered pairs. So I'd go over 82, up 4.5, plot a point. Over 78, up 4.0, draw a point. And I would just plot all of these points. We are going to use this data that I've already represented it with. So I've got that information in a spreadsheet, a Google Sheet. Lovely. We love the Google Sheets. And if I select that data, you guys can open up your sheets and follow along. I know you probably already have the graph here. That's fine. Let's see. Let me actually, for my viewers at home, let me increase the size of that. So I've got my 2 columns. I'm going to select the data. So I click and drag, making a rectangle that selects those 2 columns all the way down to cell 8. And what I'm going to do is I'm going to go to Insert Chart. Okay. So even if you already have a chart, you can and insert your own chart, and that'll be fine. And now it's going to bring up, oh, wow, I could make bar graphs comparing the temperature and the number of attendees. I can do all sorts of things. These are like recommendations. If I click on chart types, this next tab over, I'm going to scroll down and I can make line, I could make area, all sorts of graphs. Someday you should play around with this. Oh, scatter. Bam, look at that. And it even like gives me an idea of what it looks like. Right, so I make this little scatter plot, and yes, I can even then customize the scatter plot. You can change the title. You can, change different things about the axes. You can give the y-axis a name. Let's see, did I do that right? No. Ooh, that was the x-axis. How embarrassing! The horizontal axis was the temperature. All right, measured in Fahrenheit. Bam. So it's like labeling that. Then I could click the vertical axis and label that attendees in thousands of people, right? And then once I'm all done, right? Unless I want to like change, like I'm going to actually even change the size of my points. Bam, look at that. I could change the color if you want. All sorts of things you could do to change that around. And I'm going to just hit insert, and what that does is it brings my graph, my scatter plot right there. And notice the nice thing about this is it actually automatically scaled my x and y axes accordingly. Notice my x-axis does not start at 0. It starts at 60. Okay, so be aware of that. It might have done that sort of thing. There are ways you can edit all of those things, but what I'm going to do is use my graph. I'm going to actually invert colors here. Let's see. This is going to be really scary. Don't worry, internet friends. I'm just inverting the colors. Oh, no! The colors have reversed. Oh, my. Yeah, like I love these inverted colors. Here we go. And I'm going to, let's see, grab a snapshot. I don't need that dot, I don't think. I'm just going to, bam, right like that. And I'm going to go back to, where's my lesson plan? Wow, I'm super lost. I've got all my tabs. All right, let me get out of my colors because I'm scared. Back to normal. All right, and let's see. Let's go back to this, and I'm going to paste my graph right here. Okay, so there's my chart. You guys could have created that as well. I think I already had one available for you. Now let's draw a trend line for this, if one is appropriate at all. Okay, let's draw a trend line. I think I can make one. I'm trying to like first match the slope, kind of. It looks like that kind of line is maybe a little steeper. Now, like I'm looking at like this point in particular. Notice like this one point is kind of like super far off from the others. So I'm kind of like, I feel like that was just like weird data. I'm like, these ones are all together. This point is what's sometimes referred to as an outlier. So I'm not going to let it influence my line as much. So I think that's an outlier, where it's just kind of like a weird result. What data was that? That was this one right here. Yeah, so that's just kind of like a weird result. Actually, I don't even know what these attendees are going to. I don't know. We just know temperature and attendees, that the warmer it is, the more attendees there are in thousands once it gets too cold. I don't know. Maybe this is to a water park. I'm guessing. That would make more sense than attendees to like a ski resort, because no one, that would have a negative correlation. Because, yeah, you don't want to go to a ski resort when it's 90 degrees or 80 degrees. But yeah, so it looks like there's a positive trend, because my trend line would have a positive slope. So positive trend, right? And then I could even at some point predict what that slope would be. Let's see. For sake of time, let's keep moving. Oh, I've got my man. They're seeing all my tips and tricks now. They see how I invert these colors. They see how I take snapshots. All right, we're gonna use our tables a little bit more in a moment. But let's see, if I'm using lines of fit, and by fitness they're saying like what line is the most appropriate, what line is the best when it comes at representing data. It says, when data shows a positive or negative correlation, you can model the trend in the data using a line of fit or a curve of fit. Some data isn't represented linearly, but we're going to talk about lines. A line of fit is a line that is drawn on a scatter plot that is close to most of the data points. All right, so using a line of fit to model data, make a scatter plot of the data. Check, we know how to do that. Decide whether the data can be modeled by a line. Right? If it's all everywhere, then it doesn't. If it's data that kind of looks like this, I'd say like, well, that doesn't look like a line. That looks like, you know, like I would want like a curvy wave thing. And there are ways to mathematically do that. Let's see. Draw a line that appears to fit the data closely. So draw your what we would call best fit line. And there should be approximately as many points above the line as below it. And then we write an equation of the line using 2 points on the line, okay? So these points are not necessarily points that are data points, okay? So these are not the same, not necessarily the same, okay? I just want to point that out. The points on the line, you might not hit any of the points that they gave you. You might hit a bunch of them, okay? And so they're not necessarily the points. So the points do not have to represent actual data points, but they must lie on the line of best fit. So let's do example 3. All right, example 3. Ooh, I'm excited about this. Here we go. All right, finding a line of fit. So here we've got week X and sale in millions Y. We're talking about DVDs and the number of weeks since its release. So it looks like more DVDs sell in week 1 than they do in subsequent weeks. Okay, that makes sense. Write an equation that models the DVD sales as a function of the number of weeks. So let's go back to our data, and I'm going to click on example 3, and I'll make this jumbo font again. Let's see, larger, bam, there we go. And so I'm going to select this, I'm going to insert a chart, right? And I'll say, no, I think you don't know what you're talking about. I want like just the scatter plot, bam, right there, represent. Oh, good, they actually already labeled my axes for me this time. Let me right click, I can do an advanced edit. And let's make the, let's see, where's my labels? I'll make those a little larger. I'll make them, I don't know, what's a good color this time? Naranja. It's going to be inverted anyway. And so there we go. All right. So let me invert. And I'm just going to take a different kind of screenshot this time. We might hear music on this one. No, we won't. I made the music. That wasn't my computer. Just in case you're wondering. So, how'd you sneak up here, magnifying glass? Get back down there, you. Back where you belong on the first screen. Okay, so whether we made this chart digitally or we drew it by hand, which is a skill you still should know how to do, this is what I would get, okay? Get out of here, crazy X. So let's draw a line that represents this data. So you guys can do this as well. You don't have to have exactly the same line. Actually, it might be even more interesting if we don't. And let's see. I'm thinking, you know, so I'm kind of fidgeting with it. Like I can get like all of these points to be pretty close, and then it looks like I might have one outlier again. So I think that's what I'm going to kind of go for. I could give that outlier some influence, but no, I kind of want like about half of the points above, half below. I'm thinking something like this. All right, that's the line that I'm going to draw. And we'll have different answers, and I'll actually, at the end of this video, I'll show you the computer's answer to this question. We can actually get an exact, the most efficient, most algorithmically generated answer to this problem. All right, so let's pick some points on our line. All right. So did you guys draw a line on your paper using your ruler? Right. I think I already gave you the graph. Your graph might be a little bit stretched or smooshed than mine, but that's fine. So let me pick some points. This one looks like a hit. I think that one's a hit. I'm going to say 510 is a hit. I don't think I fully hit dead center on any of my other points. Let me pick a, Let me pick this one maybe. I don't know. Yeah. Or this one. Yeah, I'll pick this point. So this is, oh no, I don't want 2.5. Maybe I will use something more like 5. Or let's use the 10. Yeah, that's fine. Right. Might as well try to give myself friendlier numbers. 10 and what do you guys estimate that being over here? Want to call that a 2? Let's just call that 10 and 2. So week 10 after release, I'm predicting that it would have been around 2 million sales. And really, like any 2 points on the line you pick, they're all going to end up being the same line at the end of the day. So my slope is going to be y2 minus y1. All right, so y2 minus y1 over x2 minus x1, so over 10 minus 5. And so my slope is equal to 2 minus 10 is negative 8, and 10 minus 5 is 5. Negative 8/5, that's going to equal negative 1.6, I believe. Right? Yeah. All right, so there's my slope. And now let's plug this in to point slope form. So I'll do y minus, actually, these are perfect. I might even use the fraction for this slope. Both of these points would work well. I'll use 10 too. So y minus 2 equals negative 8/5 parentheses x minus 10. And I'll convert this to slope-intercept form. Right, I think I gave you enough space for that. So I'll have negative 8/5 x minus, let's see, 10, or actually it's going to be plus. 10 divided by 5 is 2, multiplied by 8. 2 times 8 is 16, and a negative times a negative is positive. All right, and then I will add 2 to both sides. Yeah, I ended up picking some pretty convenient points for ourselves. And I'm going to have y equals negative 8/5 x plus 18. So here's my equation. Written with decimals, that would be y equals negative 1.6 x plus 18. So that means my slope being negative 1.6, I expect sales to drop by 1.6 million for every 1 week, right? Because this is over 1, for every 1 week after the release of the movie. So this is what I got. Let's see what the computer gets. All right. Now it's possible. So click on your chart and go to Advanced Edit. So right click on your chart, go to Advanced Edit, and under Customization, we're going to scroll all the way down. You ready? Are you with me? Did you right click on your chart? And oh, okay. It gave you the left click option as well. If you scroll all the way down, you can see trend line, and we're going to do linear. Did you find it though? Oh, you don't have a right click on your laptops? Well, either way, go to Edit Chart. Right. If you click your chart, maybe you can. That's quick edit. I don't know. I don't know how you guys right click on your laptops. Oh, okay. So Advanced Edit, under Customization, scroll all the way down, go to Trend Line, and click Linear. And look at that. Whoa, it draws a line. Scroll all the way down to Trend Line, Advanced Edit. No? Here, let's see. Advanced Edit. Okay, you guys also have a little triangle. But yeah, scroll all the way down. Yeah. So scroll all the way down and click Trend Line Linear. And what it does is it draws a line. How appropriate. I can change the color of that line. I'm going to change the thickness of my line to be a little bit thicker. Opacity, I'm going to make it 100%. I'm going to change the color of it to red. Actually, maybe that's a little too chunky there, right there. Okay, I'm going to hit update, and this is my line. Now, what's cool is, let me invert colors again. Yeah, ours is going to be pretty close. Let's see. What's cool is it's actually possible. Let me actually just go back to advanced edit. I'll pull it from here. I'm going to hit print screen from that. And I'll grab my screenshot and uninvert colors. Let's see, I'll uncheck my magnifying glass. Here we go. This is what the computer gave me as their answer. All right, so notice, what is the computer's slope? I've got the equation right here. So what is the computer's slope of their line? The number in front of the x is negative 1.833. And what is the computer's y-intercept? 19.25. All right, so negative 1.833, yeah, I was off by a little bit. 19.25, yeah, I was off by a little bit. So we were pretty close to their line, and I just want to point out, like, computers have been programmed where we can actually make them give us the most close line to representing any data set. And so that's something that you can actually do to check your answer, is have it give you the trend line, and then you can even have it show you the equation like so. If you, while you're still in the edit menu, you can actually highlight the line and it'll show you. I think there's a way that I can get it to, maybe I'm thinking Excel. I used to have it show me the trend line itself. Label, use equation. There we go. Bam. Yeah, so if you go to under the label, hit use equation, it'll show you the equation of the trend line right there. So that way you can see what the slope is. I know it kind of wraps around. Let's see. I don't know. Come on. Chart. Change chart area. I don't remember how to resize it. But either way, even though it wraps the text, you can see what their slope is and their y-intercept of the line, like so. So you guys can draw your trend lines like this, and you can pick 2 points on it and find the equation using your current techniques, and then you can compare it to the computer's output. All right, so now, I want you to do both as best as you can. And I've even got tonight's homework data given to you already. Look at that, lovely homework data for all the homework problems you've already got. So you can actually select the data and make those charts and predictions. All right, well, thanks for watching, Internet friends. Have a great day. Bye-bye.